So what I want to talk about now is I want us to get back to visualization. So last class we started talking about this idea of data visualization, and we started going through the basic Tufte kind of ideas for talking about visualizations. What I would like to do is to talk about a couple of other kinds of visualizations that people see, plots that people see, and what makes them good and what makes them bad. And then go through concretely a bunch of visualizations I've seen over the years where we start to critique them. Okay, what's good and what's bad about them. Okay, any questions? Okay, so there is a kind of plot that is called a box and whisker plot. How many people have seen box and whisker plots? This is this thing, right? What is the box? That's the box. What are the whiskers? The hairs coming out of it. What is this showing? It is a way to show a, let's say, a whole distribution, okay, in a relatively small amount of space, or a lot of information about a small distribution. Here we see a graph which came, actually I know where this came from, which was looking at a bunch of different houses, circuits, things like that, and it was looking at power consumption as a function of time. And if you look at it every hour of the day, during the time when people are awake, they consume more power than during the night, right? So one way that you might typically draw a plot like this would be to find what was the average power consumption, okay, and plot the average power consumption as a function of time. Does everybody see that? Now, the good thing about that, that's essentially what the red points here are. That's basically the mean or the median of the distribution at each point. Okay? But what a box and whisker plot tries to do is to show more. It tries to show as much of the distribution as you can. Okay? And so here what they typically do is they'll show, the whiskers show the extreme points. What was the smallest value? What was the largest value? The box supposedly usually shows the quartiles. This is the 25th percentile value and the 75th percentile value, right? So it gives you some idea of what the variance is, as in addition to just the mean. Okay? Any questions about that? How many people like box and whisker plots? You like box and whisker. Why do you like box and whisker plots? You say, okay, so it's clear that there's more information than just the, than just the mean, right? Is there any other way we can show the distribution of values? Okay, that's really what this thing is showing you, okay? Is there any other ideas as to how you can show distributions of values than a box and whisker plot? Okay, yeah. Right, so one possibility that I often like, okay, is that if we show here is the mean power consumption, sometimes what it pays to do is to draw contour lines, other lines at the 25th and 75th percentile. Does everybody see that? It sort of gives you the bottom of the box and the top of the box without actually the rest of the box, right? And maybe Tufte would say that's better on an ink ratio. Any other ideas how you would might show data more than just the mean of these things? Okay? Are there any other graphical devices one can think about? One thing that I often find better than this, actually, is why not actually show the actual values? This was the mean, right? What if in another color, very lightly, you had a dot for every point that you had seen? Does everybody see that? Sometimes, in a lot of cases, showing the raw data very, very lightly enables you to see more than just this. You actually see the distribution. Too much, too dark is going to be very distracting, right? But sometimes it pays to show the points, okay? Any questions about that? Okay, or some of the points or something like that. Okay?
So you want to actually plot those points all the time?
Sometimes I will show the actual data. Really, what this is saying is you show the actual data. And if this is shown very, very lightly in a light gray, it's not going to be so distracting, right? And if you then have here the mean through it, now implicitly I get more information than the box and whisker plot, right? And I sometimes find these more interpretable. You have to look at your graph and see if you've created a mess or you've created something that's nice. But recognize small dots, light dots, can be distracting, but can still kind of convey, might not be distracting, but convey what they're doing. Okay? Any questions? Another possibility, by the way, that's even simpler than both is, at very least, you might want to show the mean and just a standard deviation. If you plot this, the standard deviation, that this is sigma above and below, that gives you more information about what the plot is actually doing. Any questions about it? Okay? So the point that I would say here is, if you're showing me a series of averages, there's a lot of sins you can hide in an average. It often pays to show more of the distribution. The box and whisker plot is one idea for that, but there's other ideas as well. Any questions about that? Okay. Another class of plots that you sometimes see are these things that I would call stacked area plots. So let's say this is, in this case, this plot, if I look at it, has to do with weapons. How many different kinds of weapons have been sold? And this is a time series of how many weapons were sold each year. You can buy revolvers, shotguns, pistols, rifles, all kinds of good things, right? Now, the total amount, if you look at this, what is good about this is, in some sense, these representations, either as bar charts or connecting them as regions, one thing it shows is a cumulative distribution of all of them. It's still possible to see what the what the actual amount is. If pistols are orange here, how would we figure out how many pistols were sold in a year? Okay, you would have to, take a look. The distance from here to here would reflect how many pistols were sold that year, right? So, what are the advantages or disadvantages of showing, in some sense, a stacked area chart of these kind of things versus a separate line plot showing how much of each was sold? Okay, do you see that this is now showing me the time series of how much of each type were being sold each year? This is the stacked area plot, right, where you concatenate them. What are the advantages of this over this? This gives you the cumulative trend, so you see that weapon sales are going up, right? Anything else that's an advantage of the stacked area plot? It gives you some idea of, again, what the relative proportions are, right? So you know that what is bigger, what fraction of it is how much, stuff like that. This is one that's just showing the individual lines here. What's better? This one better at? Yeah.
Well, I guess what makes this one difficult versus that is that you can't compare. It's hard to compare, like you said, the middle area. So are more shotguns or more? I don't know what that says. And not that orange.
Right. The orange one are pistols. Okay. It looks like people have been buying a lot of pistols here.
It's hard to say. Are there more pistols being sold at the end there, or in the middle, or because they're
right.
Pushed up by the.
Right, so it's not obvious here. There are two big bumps in pistols, and it's less obvious to me that they're really big bumps, and certainly that they're the biggest bumps of all. If you ask me which was the biggest kind at a month, it doesn't. This jumps out at you some of the trends. Does everybody see that? So which one is better, this one or this one? The answer is it depends, right? With most things in the world, the answer should be is it depends, right? But we should have enough fluency in these different kinds of devices to sort of have an idea about that. Okay? Any questions about that? Okay, good. Here's another example of stacked bar charts. Okay, this is showing by class, okay, how many people died on the Titanic. There were 3 types of tickets you could buy on the Titanic. Which was the best kind of ticket to buy on the Titanic? Actually, one on a different boat, to be precise, was the best ticket to buy, okay? But that's not given as an option here, okay? But this is first class, second class, and third class. And it shows what fraction, how many people lived and died, okay? This shows bar charts showing how many died. This thing shows fractions of it, okay? Which of these is better or worse? What's the advantage of showing the actual number? Okay. Yeah.
Well, I mean, you know how many third-class people versus first-class people want to vote in the first place.
You see something different here. You see how, what's the relative sizes of the populations. Implicitly, it tells you what your chances of surviving are in each one, right? But more than that, it tells you it gives you the absolute magnitudes, which would be hard to see. I mean, the fact there are a lot of people died on the Titanic. You don't necessarily see this here, but you see that there, right? What is the advantage of the proportionally scaled things? What was the safety level? What was the odds thing? And it was clear they found plenty of ways. In general, were able to get all the rich people off the boat, okay? But the poor people didn't do so well, right? And, and so recognize you've got these degrees of freedom, and depending upon what it is you want to show, one is better than the other. Does that make sense? That's kind of the thing that I'm hoping we get from this, is to realize what your degrees of freedom are for presenting data, and so you can learn to pick the right one. We live in a world where, because there is matplotlib and there's an infinite number of graphs in that thing, actually producing graphs is not rocket science these days, right? But you have the freedom to produce what you want. Thinking about what you really should want is what I think is the important thing to come out of here with a visualization, have some sensitivity. Any questions? So another class of visualizations that are very valuable are data maps, okay? Where you somehow have, are capturing some kind of a, using position as some kind of, to capture geography or some other aspect of it, okay? So this is showing from the previous presidential election who won each state and how many votes they had, okay? Any questions about that? Okay? And you can see when you have geographic data, it naturally lends itself to a presentation on a map, right? So again, if all of you people insist on doing city bike stuff is on a map, right? And undoubtedly, a lot of good visualizations of that are going to revolve around maps, okay? Any questions about that? What is the map on the left and what's the map on the right? A cartogram is a map where you scale things according to the value that is here. If you look over on the left, this is showing the map of electoral votes. What? This is Montana. You're right. Okay, good. Okay. So, so this is showing you a map. In the United States, the elections are different states have different amounts of votes for the presidency based on how many people live there, essentially. Okay. And some states have more votes than others, right? Sometimes you have a big state like Montana, big state, no people, right? Few votes. So if you look at that, though, if you look at these maps, again, typically in these maps, sorry about that, red is the Republicans and blue is the Democrats. When you look at this, you say, hey, why wasn't the Republican president, right? Because they have more red than blue, right? Here we have a map where we scale it according to the size of the thing being represented, right? So where is Montana now? Can anybody see Montana? Where is Montana? There's Montana, little Montana right over here, right? Does everybody see that? And this shows Montana as not being so very important. Is that right? And a cartogram is a map that has the property that it tries to preserve the shape as well as possible while distorting it so the area reflects the variable. Does that make sense? And now when you look at the cartogram, you can see Obama won the election, right? There's more blue than red on the cartogram, whereas that's not really necessarily true on the what you call it, on the regular map. Any questions about that? So data maps are a very, very useful thing, and they don't have to necessarily be about geography. Okay? This is, in my mind, the world's greatest data map that was ever produced. Okay? If you look at it, it's the periodic table of the elements. It sort of did come up with a drawing of things, okay, such that positions, seeing them where the positions are, does tell you a lot about what's going on. Okay, you guys took chemistry at some point in your lives, right? And on this one, you kind of get the idea, yes, that things are similar across columns. Is that right? Is that right? And that the organization of rows has some meaning here, right? And I mean, they were able to predict new elements they hadn't discovered because there was open spot on the map, right? So I think this is the periodic table should be an inspiration. Often there are things that you want to draw, data that you want to represent, that sometimes there is a figurative map-like presentation for it that isn't necessarily just geographic. Any questions? And people who drew the map made some intelligent decisions to make it visible. Okay? So everybody knows this is the, what you call it, the periodic table. Why is this down at the bottom? Does anybody know why these things are down at the bottom? Okay? They really, all of these things really belong in here. And all of these things really belong in there. Now, what kind of a decision could they have represented that in these spots? You say no. You sure you could have. You could have intelligently done something like this and had this cell be like that, right? And then it's really in the right place. Or you could have blown the table up further wide, right? And made it so that this was the right amount. But there were the other atoms, like the one above it, your bitium, would be like this. And the entire periodic table, whenever you saw it, you would only see your bitium and, what is it, Scandinavium or something like that. Right? Does everybody see that? So there was the guy who developed the current form of the periodic table. I don't know if it was this guy. I know there's the famous Mendeleev was the guy who developed the periodic table. But I don't think any of these may have even been discovered by the time he was, I don't know whether they were discovered or not at the time. But recognize that there have been decisions made by clever chemists and visual people to make this an interpretable thing. Okay? And that should be an inspiration to us. Any questions about that? So maps are a good thing, and sometimes they're geography-based, and sometimes they're, an example of maps that sometimes are not geography-based. Often you have networks. There are network drawing programs that will try to lay out a network, in such a way as to preserve its structure as well as possible. That's a good example of another data map. Any questions? Good. Okay. So, the major lesson of this is that I hope it kind of comes across is that if you use Python, matplotlib gives you a way of making an infinite number of things. If you use R, there's an even larger, I think, number of visualizations. Just because Excel draws a graph or a table in some way does not mean that is the right way to draw it, okay? And so there are a lot of, very bad visualizations I see. I look forward to seeing your projects. I know there's going to be a bunch of terrible visualizations in them. And I'm going to try to call people out on that. I'm looking for bad examples to put in my book, okay? So I want people to be a little sensitive here and to try to, when you have a graph, think about what it's trying to say. How do you make it say it? Any questions? Okay. Some other ideas that come up in making plots better or visualizations better. One idea that is an idea I like to see is that small multiple plots or tables are often an excellent way to represent multiple, multivariate data, okay? when you see arrays of tables, okay, you're naturally supposed to make comparisons across them. Why you have a visualization? You want to fuel the eye making comparisons of things, right? And often, a relatively small table, in this particular case, it looked like there were 4 different criteria, actually 8 different criteria, and 4 sets of tools, right? I mean, in this long set of tools, right? And naturally, when you have comparisons like this, the eye wants to do things. It's pretty clear nobody is doing predictive analytics. It's pretty clear that a lot of people are doing parameterized reports on what are the popular tools and which do people like. So I always find it is very good to think in terms of multiples, okay? Because one good thing when you have multiple schemes, plots that are basically the same thing in an array, it takes some time to figure out what one of the plots is doing. But if you've got an array of plots, now once you've learned how to read one of them, it's easier to sort of look at them all. Okay? So this is a device that I kind of like to see. Any questions? Okay. One thing that modern plots that we should think about a little bit is how does one use color on graphics? These days, you know, we live in a world where everybody's computer is a color computer. Even your printer is a color printer, okay? And it's natural and a good idea to use color in graphics, okay? Now, color is a complicated thing. There's various different systems for how you represent colors, okay? One of them represents every color by a hue, which I gather is kind of the, you know, what I think of as a classic color. And there's different shades depending upon how bright it is, meaning how much it's mixed with something that goes from white to black. You could imagine that the brightness of a color is a function of the color, the raw hue, and you mix it with some, equally perhaps, with some value that goes from white to black. Okay? Alternately, there's a notion of saturation, that you could kind of have a mix between, you know, on one end it's gray, and another end is, in one case it's fully gray, and another case it's not gray at all, okay? And the color is kind of a blend, a linear combination of these two things, okay? In general, any color you can make can be described as a mix of what the hue is, the saturation, and the brightness. Any questions?
Like, do these different parameters like saturation or brightness, do they convey something like implicitly? Like, do they mean something?
So what do they convey? Let's think about it. What would the idea of taking a color and modulating its brightness do? Okay? I think there is a linear order here, right? You could imagine if we were going to be talking about, let's say, the popularity. Let's say we wanted to make a map where we were recording something on the map, how happy people were, how rich they were, how long they lived, or something like that, right? It would make sense to color the regions of the map so that they, you know, reflecting the number, right? So you could see visual patterns, right? Which is a better way to represent the color scale? Is it with something like brightness or saturation, or is it with this hue of having lots of different colors on it? Okay, what? Saturation or brightness, to my mind, there is a linear order here, right? You have a scale that naturally goes from lowest to highest. Is that right? Lowest to highest. In a color map with a lot of colors on it, is there a natural order of lowest to highest? You could do cool to warm. So let's think, what kind of color scales are there? I guess that's important to think about it. Cool to warm makes sense, but cool to warm is largely, I want to claim, a saturation or brightness kind of a scale, right? What do you think of as cool to warm? Give me a scale of colors from cool to warm.
Well, the middle I don't really understand, but blue to red, and then blue, yellow.
Blue to red and then you say to yellow, and then you're confused, right? Okay? I mean, I will confess that I have used color maps that I have liked, where I had, naturally, white was in the middle, okay? Blue was very low, and red was very hot. Does that kind of make sense? And now I use this brightness scale to kind of have it go from dark blue to dark red through white. Does everybody see that at the end, on one level of my brightness scale, okay, I can make it be white. Or maybe it was a saturation issue, right? More a saturation scale, where I have a linear combination of a certain amount of the color with a certain amount of white, right? What's good about that is people do have the idea that blue means cold and red means hot, right? And you can now see that gradation. So what I kind of want to convince you, if you want to talk about a color scale, typically you need a linear ordering of your color scales, right? And usually sticking to one color, or maybe two colors with reflected around the center, is about all I can do to maintain a real scale in my head, right? If I want to show a lot of values here, obviously the color, it's much more colorful when I have a rainbow. It's harder for me to keep track of the, of what the linear scale is of color stuff, right? On the other hand, if you're trying to show that regions are different and you show the scale, sometimes a rainbow scale can be useful. But recognize that if you're really trying to make people get an idea of more versus less, they're probably better off with a scale like this than a scale like that. Any questions? See, again, is there any way we could make a rainbow scale perceptively, in a way that we could remember what the ordering was? I always thought the order of colors on the rainbow, right? Violet, indigo, blue and green, yellow, orange and red. Okay, so there is a little bit of an encoding here, right? But I still think that you couldn't pick up on that in general as easily as you could from this, right? Any questions? So using color in a sensible way is an important part of visualization. Any questions? Okay, so any other questions about any of the devices we have seen so far? So what I'd like to do for the rest of the lecture is I have a bunch of different graphics, and I want us to now try to critique them and see what we like and what we don't like, okay? And I think that, again, my hope is that at the end of this, one will have developed some kind of an aesthetic to it that, perhaps uses the vocabulary we talked about with Tufte, things about data-ink ratio, or is the graphic lying? Is there junk here that doesn't really add to the visualization? Okay? Do we have proper labeling? Things like that. Okay? Any questions? So when I think of what is a great visualization, I think of something that shows data in a way that it tells a story, that it makes you want to keep looking at it to see more of the story. That's what I think a great visualization is. Now, when you read Tufte's book, this is Tufte's favorite visualization. This was a visualization from like 1812. And what was this a story of? This was a story of Napoleon's army in the war when Napoleon, War and Peace, right? And what is this thing showing? What do you know about Napoleon? He invaded Russia. It was a bad idea, right? How was it a bad idea? This is showing the size of Napoleon's army as he's marching along, right? And what happens? At one point they split, and at one point they went down, and at one point... And what's this showing? The thickness of the line is showing what? How many troops does he still have left, right? And what does this suggest as we go back here? And he goes to Moscow. Things are looking good, but then he realizes it's not be better get out of here. And looking at this, it's kind of capturing the idea that you're capturing both time and space here, okay? You're capturing time, you're capturing space, you're capturing the size of the troops, okay? This, to me, is an excellent story of what happened. Does everybody kind of get that? So this is a classic one. What? What? This is the retreat. So he went, these guys all marched off And then they got to Moscow, and they discovered that Moscow was cold in the winter, and that they had to get back. Okay, and you know, a lot of people died along the way, right?
It says that there was 10,000 men when they returned, and it started with 422,000 men.
So, you know, many of them must have died. Some of them may have been captured. Some of them may have deserted. I don't know exactly. But this tells me this was a bad idea, correct? Does everybody get that idea? And it says it in a memorable way. Okay, this is one of my favorite charts each year. Okay, I read the New York Times, and every January they publish this, which is the weather of the New York City weather for the entire year. So what is this showing? Okay, this is showing for every day of the year what was the high and low temperature of that day against what was the average high and low temperature of that day against what was the record high or low temperature that day. Does everybody see that? Over all time. Does everybody see that? Right? So when were records set or nearly set? Can you see that? Yeah? This time looks like this must have been hot, right? Hot time, hot time, hot time, cold time, right? Does everybody see that? And, you know, you see this, the arc of the seasons and stuff like that. When was an unseasonably warm period? You're saying April? April to me doesn't look particularly warm. There was a very hot spell quickly. But generally speaking, April was not a warm thing, right? Isn't that interesting? Isn't it funny how you can go from having a pretty cold, unusually cold April to having that quick moment in there that was suddenly really hot, right? November was very hot at the beginning, and November had a big spread, right? It was very hot, unusually, almost record high and almost record low, right? I'm looking at December, the end of December. Here, clearly, it ended the year, it was much warmer than it should have been, right? And to me, I can look at this thing for a long time. Look at it. This is the kind of thing. Look at this day. My God, the high that day was less than the usual low. Okay? These people must have been freezing their buns off then. Is that right? Okay? So to me, this is an amazing thing. It is showing 3,000 numbers here. Okay? In ways that I can understand it and look at it and see a story that is being told. Does everybody see that? And there's even more numbers. This tells you about rain. How much rain did you get each month? That happens to be down here. Okay? And, you know, and so anyway, this to me is a great thing because it's a lot of numbers, but no confusion, and it makes you want to look at it. Yeah?
I have a doubt. What is that blanket around the
What is what?
What is that blanket around the graph that you're talking about?
Blanket. What do you mean by blanket?
There's a red graph, right? The lines are red graphs. For that day, the highest...
Wait, you mean this thing?
The light yellow region around it.
The region around it. Oh, you mean this? This is showing you the record high to the record low.
The actual value?
The actual value of the record high and record low of this day over all years in the past. The hottest it has ever been in New York on January 30th, which happens to be my birthday, it looks like 60-odd degrees. Okay? The coldest one looks like it was actually about 7 or 8 degrees that day, right? Does everybody see that? And you can see how again, I like to watch how the thing flows over the year. You know, the fact is that, that it does get warmer in the summer, okay? And although there is some erraticness, anyway, I can look at this for a long time, and that to me is the sign of a great visualization. Any questions? This is a train schedule, another one of Tufte's favorites. This is a train schedule that was built, okay? You guys take the train from here to the city, right? Does your Long Island Railroad schedule look like this? No, but what is this showing you? Okay? The x-axis is the time of day. I know, the x-axis, yeah. The x-axis here is the time of day. The y-axis is the position of the train between Paris and Lyon. Does everybody see that? And so what does this tell me now? If I wanted to look at this, when do I have to catch a train to go to Lyon? If I wanted to go to Lyon from Dijon, how would I figure out when I got to be there to be a train? I look at whenever I look at Dijon and I see a line going down to Lyon, that's when I have to be there, right? There's a train to Lyon. There's a train. There's a train. There's a train. Okay? Any questions about that? Okay? What can you see on this thing that you can't see on a normal train schedule? Yeah? The speed of the train. How fast which trains are faster? Steep slope means the train is faster, right? What else can you see at this train with this kind of a visualization? What? Timing? Well, okay, you get a sense of when it's at a station. That's true. What other things do you get to see? It tells you something about the gap between trains. Like here, it's clear that there's a lot of trains traveling at this time and relatively few at this time, right? Any other things that you can get on this train schedule?
Many trains with overlapping like timings, then you might not be able to differentiate between which line is going like right first to cross, like you cannot differentiate like if there are many
Okay.
trains,
Okay, so I can kind of agree you get business train. What other things can you get here? What? Bottlenecks, maybe to tell you that thing. Tells me when you stick your if you stick your hand out the window, it'll get cut off by another train. Okay, what? Well, that's okay. That's not a problem that there's many trains running at the same time. The question is, how do you know when your hand will get cut off if you stuck your hand out the window? Whenever there's an intersection point, this is an accident waiting to happen, right? If you're afraid, oh my God, did they switch the train right? Okay, when am I going to see a train pass me? This is the one. Those are the intersection points. Okay, so there's a lot of things here that you can see in my mind that are kind of cool that you can't see with a regular train schedule. You can't pick up the exact minute maybe of when your train's going to be, but there's a lot of things that are interesting here. Any questions about it? And again, a good visualization, you see data in a different way. Yeah. Is it too crowded? Well, what I would say that I don't like about this is that the grid is too oppressive. Okay? If I were going to be drawing this thing, you do want a grid because you do want to be able to look this thing up, but I would definitely use a much lighter grid. Okay? And it would look less crowded. You know, as far as is it crowded, well, this is how many trains you have. You know, if you really, and I think I can read this and follow it and see patterns and stuff like that. Okay? I wonder why do they bother to send a train from Macon to Lyon? Okay? That's kind of interesting to me. Okay? And so anyway, a lot of it I claim. So anyway, a good visualization, you see different things. Does everybody agree? Okay, has anybody ever seen this map before? Yeah. This is kind of one of the famous maps in science, okay? This was cholera, was this terrible disease that people were getting and dying. And in London, there was a cholera outbreak in 1854. And in order to figure out what it was, this guy made a map of where was it that everybody who died of cholera was. Okay? And he noticed that when he looked at this map and plotted it, that all the deaths seemed to be centered around this point. Okay? And this point was, where there was a water pump. Back then, people didn't have water going to their house. They had to go to the water, to the common well. Okay? And that it turned out that the handle of this pump was infected. And ultimately, all they did was they changed the handle on the pump. And suddenly, there was no more cholera. Okay? But it was kind of thing that with a data map like this, he was able to see where there was a concentration and make a theory about it. Okay? And any questions about it? So these are famous classical. Here's another plot that I think is kind of interesting if you read Tufte's books. there was, back when in 1986, and I was in grad school, the United States had a space shuttle that blew up on takeoff, okay, the Challenger. And what had happened was that day that they had launched like about 30 or so shuttle missions before this, and the engineers, the day they launched this shuttle, it was much colder than any day that they had ever launched it. And the launch engineers tried to convince management, okay? They said, when we've launched shuttles in the past, they seem to have a little bit more damage on the days when the temperature was lower. And so they gave a presentation which had this figure, and they said, look at this figure, okay? You can't launch the space shuttle. People will die, okay? And management said, you're a bunch of eggheads, and that's the end of it. Okay, we'll launch the shuttle, right? Now, Tufte redrew this data. This is showing the amount of damage, okay, to each mission, where he had the temperature on each mission. Does everybody see that? Now, what Tufte said is, let's take that data and redraw it, where for every mission, I'm going to list the amount of damage and the temperature it was. Okay? And he said, here's one mission, here's another mission. He's showing every one of the missions how much temperature there was. He's saying, look here, see how as it gets a little bit colder, there's more and more damage. And look, this is where it's going to be launching today. Does everybody see that?
So that was they knew ahead of time that there was the possibility of that the cold interfered with the O-ray?
Well, what they didn't know was they saw that there was, they're carefully measuring things about the mission, and undoubtedly when the mission comes back, some days it comes back sometimes in better shape than the others, right? There wasn't a strong, none of these damages were enough to threaten the mission, okay? But the engineers said, maybe I'm worried about this, okay? And they get nervous. And of course, the engineers are probably always nervous, okay? So the management learns not to listen to them. But what's more than that, when you look at it this way, and he shows what was the actual temperature that day, suddenly you see, wait a second, this is wildly different, and there's a reason to believe that something bad is happening with temperature, right? Why don't we wait for a warmer day? Okay? And this is, I guess, a good example because if you look at it, again, like this is the presentation they gave, this is the presentation they needed to give. Okay? And it's kind of an inspiring thing about why, it's important to think about what story you want your data to tell and how you make it tell. Any questions? About 20 years later, another space shuttle blew up, right? And if you read Tufte's later books, he'll show again the graphic that the engineers tried to use to stop, said, oh my God, there's going to be this damage to the tiles. And they drew up these graphs and management couldn't understand it. And they said, bring it in. Okay? And if you redraw the data, yes, you can start to see that there's a problem. Okay? Any questions about it? So those are what I will call, this one I'm not so excited about. Okay, so those are good presentations. Let's look at the kind of things that I see from students more regularly. Okay? So here is a graph that I saw from a student. Okay? And this is showing me the frequency of words. Okay? As a function of how popular the words are. Okay? What do people think of this plot? What? It's awful, okay? Now, how do you make it better? Okay? Okay, first of all, you say get rid of the outlier. One possibility is to delete the outlier. Okay, that's an immediate thing to try to do. It turns out that probably wouldn't help it in this case. Okay? The idea of putting it on a different scale, okay, is a better idea. Okay, if we put it on a log plot, this is what we would have. When you do a log scale on here, suddenly the outlier isn't such an outlier, right? And why wouldn't deleting that outlier be enough to solve the problem? Because this was a power law plot, right? If you delete the outlier, what's the next point going to be? An outlier. Okay? And you delete that outlier. What's the next point going to be? An outlier, right? That there's basically going to be a hierarchy of outliers. Okay? So if you plotted it on a log-log plot, look at this. Suddenly this thing goes away. Okay? This thing becomes meaningful. And if you plot it on a log-log plot, you start to see that, yeah, this is really a power law. Okay? Any questions about that? So when you see a plot that has nothing on it, this is a bad idea, right? Any questions? Here is another graph that a student gave me, okay, which is showing they have genes. Genes have positions from left to right, and they're measuring the energy at each position on the gene. Go from left to right, okay, on average over all genes, okay. What does this plot show you? Okay, when you look at this, what are you seeing?
A lot of variance.
No, it is not incorrect. It is not correctly plotted because you have distance at both the sides, right? So you are actually adding this thing, right? Like, so it is twice of what is the actual variance.
I don't know quite what you're saying. You're saying you're seeing a lot of variance, okay? Now, the student who was doing this said, look at this. The energy goes up as you go to the right side of a gene, right? Does everybody see these values are much bigger than they were then? Okay? And is that what you're supposed to see?
No, because there are also huge gaps.
There's huge variance. Can anyone imagine why there was such variance here on a plot like this? She was showing what was the average energy at a position averaged over a bunch of genes. Most genes are short. Okay? This is showing the length of the number of genes of a given length, right? Does everybody see this? And so for up to 500, there's about 4,000 genes of length 500. And very, very few, less than, only a couple dozen above 1,000, right? So what does the figure look like? She's looking at this and saying, wow, look at it going up. It's not that it's going up. It's that you're averaging over very few things. You're seeing variance here. You're mistaking variance for signal, right? And that what you should see is that it's pretty darn flat over the region you actually have data for. How would you improve this chart? Does everybody agree that if I deleted this whole part of the chart, because there wasn't enough support for it, this would be a much better chart. Does everybody see that? Maybe I could use a median if I wanted to do it. But again, I think that the bigger problem is that you're taking very, very small numbers of samples here, which wildly are different. This part measured on 100 things is completely incomparable with that. The variance is so high that what you're seeing here is variance, okay? Any questions? So interpreting variance, overinterpreting variance is a big problem here, okay? Any questions? Any other way that she might have reduced the variance, however? Okay, if she wanted to do this. That might have made it clearer. One was, instead of plotting the variance at every position, what if at this point, as we get out there, we plotted it every 10 positions or 20 positions, and we now are averaging all those positions together? Does that kind of make sense? Okay? And now, if we're averaging over more things, we would expect a smoother signal. Okay? But any questions about the idea of variance here? Okay? A lot of things people see that they think are signal are variance, and you got to be aware of that. Any questions? Okay. Now, there are also professional visualizations that are terrible. And there's a site called WTFviz.net. What does WTF stand for? Okay. Okay. So it's worth taking a look at it. But here's some thoughts I got from that. Okay? Here's a pie chart. Okay? What is wrong with this pie chart? Okay? Takes a lot of... How many numbers are on this pie chart? Does everybody see that we could have represented this perfectly well by replacing the colors here by the actual number? And this tiny thing would have conveyed all the information that that thing has, right? Okay, so that's a bad thing. What do people think of this bar chart? Okay. Any comments about this bar chart? Well, recognize there's a difference in overly complicated. There's questions of how much data there is, which might be complicated if there's a complicated story to tell. But what is this thing trying to tell? It looks like there's two dependent variables and a and a two independent variables and one dependent variable, right? Any way we could improve this chart? What? Stack bar chart. Okay, maybe, don't know. Okay. First of all, the people like the cylinders here. That's kind of a nice touch, right? Okay, the 3D cylinders, right? The people like all the lines on it here.
I mean, I think it's necessary if it's 3D.
It doesn't have to be 3D.
I would probably say it doesn't have to be 3D. The question is, does it have to be 3D? I would have probably preferred to see 3 different 2D plots, a small multiple thing. Does everybody see that? And I would probably prefer something like this, okay? Perhaps you could even show 2 sets, 1 to 3 multiples, 1 5 multiples. What? So stacked array of bar charts. Now recognize that these are independent. This is showing the average level as a function of time, okay? So it's not, so time would be typically this dimension. I don't know that stacking it. Oh, I see. So what you're saying is another model would be that the way you would draw it would be as a function of time probably, Q1, Q2, ... You're going to show me of the population. What is the population that has, which levels, right? This is going to show me the level of each population. And that might very well be a more effective way of doing it. If you ask me, I probably believe that would be more effective. Any questions about that? Any other ideas? What about this bar chart? Do people like this bar chart or this pie chart? What is it that people don't like about it? Okay. Well, why are there colors? Colors so you can tell them apart, but why do you have the rainbow and multiple things per thing? The answer is because it's cool, right? Okay, and that's the thing that one has to learn to.
There's like random heavy diesel oil is supposed to be comma at 0.6.
Well, comma. I gather that it should be heavy. I gather the comma was they wanted it to be. They're showing the number after a comma. We agree that the labels are bad, the colors are bad, the 3D thing is bad. Okay? Any other ideas? Okay. Okay. What about this thing? Here you have home prices going up each year. Okay, is everybody what do we like about this bar chart?
The colors are too similar.
You're saying the colors are too similar? I would say the problem is that they're in shadow, right? Why is it 3-dimensional? There's no reason for it to be 3-dimensional. Why is this other part separate from what we have here? Okay, I don't know what's going on here, right? But my instinct is that this is I don't see this as being easy to interpret, okay? So, again, if it's supposed to be last year and then adding something on top of it, they should probably be next to each other. I don't see why you would want them separate. Okay, here's some pie charts showing, I guess, something about how many basketball teams there are in each, in each division. Okay, men compared to women. Okay? What do people like about these oval pie charts? Is that right? Okay, what? Like you say, you feel like eating them. Okay? The pie charts are oval. That doesn't help. You know, chart junk, Tufte would say that the wood, the basketball court beneath it, would be chart junk if you're really showing data, right? Okay, here is a graph showing the amount of debt in a household as a function of time. What do we think about this particular graph?
I think the scale
The scale, first of all, there's no axis labels. If there were axis labels, if we go back to here, we would see that, in fact, this is from 15,000 to 16,000. It's obvious that they're not starting at 0, right? And that makes a big difference here, right? Is debt going down? It looks like suddenly everybody's out of debt. Okay? But the answer is no. It's not that everybody is out of debt, right? It's that there's very little change, actually, from, you know, it's a little bit better. But not a big difference, right? The targets are right. The targets are right. Why is this target bigger than that target? Okay, is this showing that this is better than that? Okay, I guess they're trying to highlight points. You could imagine having points highlighted, but the targets serve no purpose. Okay, and the scales make it impossible to interpret, right? Here is a set of multiples. Remember, I like the idea of multiples of things. Okay, and you know, where you have a lot of things you can visually compare next to each other. Are there any sins here that people notice with this one? Yeah?
Well, 74% and 84% don't correspond to the coloring of the circles.
74% and 84%. Does everybody see that in this case? Again, I don't read the language this is in. I think this is Malaysian. See? Yeah, there you go. Good. But what do we know? That in Malaysia, they don't seem to know that if they're trying to show the amount of coffee, it would be much clearer if the thing they're measuring, here it's the white and here it's the green. Does everybody see that? Well, one is 74% of something. I mean, this looks like tea. And this looks like, I'm not sure this is coffee or tea. I mean, coffee or tea look the same at that level of granularity, right?
But I guess they call it differently because they're like, these are different things, but it is confusing.
Well, no, if they're talking about, if they want to say 23% of the people drink tea, then that would make sense. But the number here that you're supposed to be comparing something that you can't compare, right? And does everybody see that he did this throughout the entire story here, right? 74% blogs, 76% live events. Okay? Do you see that having consistency across multiples is essential if you're going to try to get a visual comparison of them? Right? What's big and what's small and how big a difference is it? Any questions? So this kind of consistency is important. Does anybody, what do people think of these charts? Okay? Okay. If you look at this, it's pretty clear that, as far as I can tell, these numbers, these charts have nothing to do with those numbers. Right? Difference between 20 and 19, 19 and 9.2, okay, down to 4.2. Does everybody agree that this has absolutely nothing to do?
But also, I mean, like, what is it? Annual trees grow? Like,
well, trees grown. How many million trees are grown in a country? Okay, I'm assuming this is millions, but I'm also assuming that the only thing that this conveys is that trees have green leaves or something like that. Does everybody see that? Yeah. What about this one? What is X and Y? And what are the dots? This is a chart that says this is a chart, right? Okay. What do people think about this kind of color scale? Okay. It is difficult for me to see what the advantage is, for example, of having this color scale versus finding a way to label each bar with the words near it, right? By the time you make the eye switch, the fact is that they didn't have enough colors, they had to repeat these things. Okay? This is a problem, right? There's too much going on there. Okay? What kind of sins do we see with this graphic? Typography, maybe the typography, but what other sins do we see here? Okay. What is that? Scale of the circles, okay? According to this, how much bigger is college compared to high school? If I look at the circles, they're pretty much the same, right? But this is supposed to be 3 times as big as this one is, right? And that's not conveyed here at all. That 3% postgrad, the grad students of the world, are a tiny, insignificant shrivel, right? And you don't get that from looking at this.
But then they couldn't have fitted the words high school and post.
So they couldn't fit the words. So this is the kind of thinking that undoubtedly a graphic artist said, but we can't put the words in there. Well, first of all, you could put the words outside it, okay? Or that may be it's clear that it misconveys what it's trying to show. And the same thing is here on this map. Does everybody see this? Looking at this, I'm assuming that they're trying to have the map scaled to what the size of the, if you think about it, this is a pie chart drawn on a map. Is that right? Yeah. And they're trying to show that the pie, I guess they want the size of the pie to reflect the proportion of the community. But it's clear it doesn't do it, right? That if you look at these scale sizes, this is not, the sizes of the regions aren't right. This is less violently wrong than the other one. Any questions? What do people think of these plots? Okay. Okay. It is obvious that this is impossible to read, right? And even if you manage to see this at the right level, it would be impossible to follow it back to whatever this thing is. Okay? Does everybody see that? So, I mean, the thing that makes it cool is this network, but this network has obviously no possible meaning, right? Have you seen a plot like this one here? This one is a plot where it's showing you for each of, for each of these parks, something about whether the value is up or low. Does everybody kind of see it? It's like a circular plot showing percentages. This probably would be better off just with a simple, line, X being the labeled, bar chart essentially, where each different category is there. Any questions? But you wouldn't see the map. It's sort of like it's not a pie chart, I think, because these things aren't adding up to 1. Some things are showing increases and some are showing decreases. This is negative 24 negative 12, and this is 73, right? But it's clear that whatever is hoped to see is completely overwhelmed by the map and all the junk and stuff like that. Any questions? It's obvious a bar chart would be much better for this, right? And you'd show the negative ones in red below the axis, you would know somebody lost. Any questions? What do people think of these, these bar charts? Look at the left. What do people think of the bar chart? What? No level for what? Wait, on this one. Does everybody see that this is 307, 37? This is the axis here goes to 35,000, right? At some point, they probably meant to multiply this by 10, right? But that's kind of important to get that right. And what is wrong with this one here? Okay, this is showing that
20% machine, human causes per accident.
Right. They said that in the old days it was 80% machine error. Today 20% human errors, and they flipped the labels. Is that what they're saying?
Yeah, because the machine causer should have been the smaller version on the right? But instead it's
Right, so this should have been right. It was human causes because they didn't have enough machines to hurt people, right? And now they got the labels wrong. They reversed what human and machine, right? Okay? And of course, these are the kind of things that matter, or else you can't interpret what you're doing. Any questions? What do people think about this one? Okay, does that look like a good graphic? Or I think this one goes without saying. What? Some of these are magazine-y, but notice that again, what you're typically going to do is there's going to be some graphs that you produce in the course of your work so you understand it. And there's some for presentation. When you're putting together something for presentation, you're working hard to try to make it look good. That may be making it magazine-y, but despite making it magazine-y, it's clear that whatever's going on here, you're never going to figure it out.
Again, most of these things are like made for general public, so general public are not very technical oriented.
It's not a question that the general public isn't technically oriented. The general public could have very easily understood a bar chart. What this is saying to someone is, maybe they're thinking, oh, my audience is too dumb to understand my data. They need something else to decorate it. Okay? I don't think that if you have an interesting data set, the audience will understand it.
I think that's one of the things, that people don't care about the interesting data set, they care about the cool graph.
Okay, well, hopefully I have sensitized you guys at least, to where immediately cool graphing is not the be-all and end-all here, right? Here's, I guess, some more cool graphs and stuff like that. Any questions? Yeah?
Won't the medium of delivery of the graphs matter?
Won't the medium of the delivery? So you're right that sometimes there are graphs that are going to be in a paper and some are going to be on your screen and some are going to be... So you're right that there's some... Part of the question is, how is someone going to see your graph? Makes a difference. Which one don't you like? This one?
So this graph, if it's ported on a digital interactive medium, this will be a very good graph.
So you want to say that the one on the... I think this one you're trying to say. You think that this might be good if it was an interactive thing, where if I click this, something glows on the other end or something like that. Maybe, except I don't know why the twisting is happening.
Yeah, they might be like they are connected to multiple.
Well, is that what it looks like? That's not what it looks like to me.
If it's like that,
My instinct here is that these are all, indicative of what the color is. This is essentially a color code for it, right? And so I don't think that it's not a question of, sometimes when they're interactive graphics, it can be different. I didn't decide to talk about interactive graphics, which are, these days a reasonably important thing. But again, you don't want the interactive graphic to be interactive to be cool, but to show something.
About a timeline. So,
What?
this chart seems to be about a timeline.
I don't think this chart is about a timeline at all. I don't see any evidence of time.
On the left,
On the left, if you were born here,
so they could have made
this is what your favorites were. What?
They could have changed this same graph to make it convey more information by making it.
It might have been better to convey it left to right, how old you were, right? It might have been that you convey, this whole thing I don't think really tells you very much. If all that it is a color code.
Or it may be the NBC logo or something.
Okay, anyway, don't know what it is, okay? But bottom line, I guess I'm going to leave it here, okay? Again, hopefully with the visualization stuff, it has sensitized you that there are principles to looking at these graphics, okay? And that the question of what is cool, okay, is not the be-all and end-all, okay? And when you look at a chart, hopefully now when you look at a chart, you will say, is this a good chart or a bad chart, okay? And like I say, when you have beautiful data, it deserves a beautiful visualization. So, any questions about that? Okay, with that in mind, I will end this here.